nothing
to debate. We won't know it.
Yeah. But the implementation. So I was looking for Grant around because he's looking at Budapest picture and new stand-up and stuff like that. So
Is he here today?
I thought so, but apparently not. But he's on IRC.
Yeah, he was on IRC earlier.
On the UDS Tokai channel, so he must be around. Someone be interested in taking minutes?
My first UDS on it.
It's okay, just note everything which you find is interesting and any questions or summaries, discussions, whatever you can just think of on the Etapad page. You know where it's in?
Yeah. I mean that one.
Yeah.
I've got that up, but do I need the video out?
If you like, yes.
Trouble is it's a Mac.
It's okay. Do you have an adapter?
No, I was going to do it. I'm not the best person to do it, Nick.
That's okay.
Wow.
So, to frame the power space a bit. In general, ARM server are going to happen. You might have seen the talk by Dave Rosley at lunch, and we know it's going to happen, but ARM servers are likely going to be different from what we think of as the Linux server at the moment, like the x86 box, which is very powerful and then hosting tons of services and has lots of storage and things like that. It's all going to look a bit different. So ARM server needs to be prepared a bit. We're starting to see chips which are interesting to run in server context. It's going to use less power, but also clearly it's going to be more servers, like more nodes and probably smaller servers than what we see in the x86 world. In server space, one of the important things is network boot, because it allows having stateless hardware, and you can deploy your machines remotely, control the master image centrally, and just deploy to many nodes and run that image in many places. Now the question is, how do we support that? So what are the use cases for network boot? What do we do at the machines which are booting? What do we load with the network exactly? What do we prepare beforehand? What do we do at install time? Which boot step do we take? Like, what are the actual software pieces involved in the network boot? And which bootloader we use? And do we use NFS? What do we keep over the network once it's booted? And then in practice, what do we implement? What do we develop out of the requirements? Do we want to implement a prototype which is based on some specific standards, or is using some specific SOC for demonstration, or just QMU or whatever? So these are all the open questions which I've got in the blueprint. So first of all, I'd like to hear from you, perhaps, what kind of use cases do you have for network boot? What do you want to do out of network boot for your own needs? How do you envision ARM 7 happening? So maybe I should pass the mic to you, because
I'll start. So what we've done, we as Calzada, is Pixie boot support to adding that to U-boot. We plan to upstream that within a couple months. And it's basically doing Pixie Linux emulation. So Pixie Linux is more than just the Pixie protocol. It's kind of the menu system is specific, I think, to Pixie Linux.
But what do you mean it's more than a Pixie protocol?
So the Pixie protocol, I think, is this basically TFT, DHCP and TFTP extensions. Then what you load over that is the Pixie Linux configuration, and then based on that you fetch your kernel and init your images.
Okay. And so what's the more part? You said the Pixie protocol is an extension to THCP, TFTP. What is it more than that?
Basically the parsing of the Pixie Linux configuration file that you download.
Okay. And the logic behind it, like in general, what you do with
Right.
it.
The Pixie protocol does things like search for paths based on address or IP address, and it searches for starting with very specific, the full MAC address, and basically chops it off until it finds something.
So one thing I like to challenge immediately when I hear that you implemented Pixie boot in U-boot is you need network support in U-boot before you do that. And so your SoC needs to be supported with its network interface in U-boot itself.
Right.
Now some SoCs, like for instance regular Beagleboard, Bandboard are using Ethernet off USB, and it starts adding a lot to what the bootloader is supposed to do. So do you think that's a recommended way for any server SoC or SoC aimed at server workloads that it should support?
No server SoC would ever hook up Ethernet over USB.
Right. I've lost connection to Ethernet.
Yes, so have
that sucks.
Was that no server SoC would hook up through USB?
Would put Ethernet through USB.
There will be a bottleneck.
Doesn't the Marvell and the Onet 4 do it that way now?
Yeah, but they're not necessarily server SoCs.
Marvell is. They're selling them as NAS boxes.
Actually, the gigabit Ethernet is not on USB.
Yeah, it's on PCI interface. At least with the old Marvels, that's just PCI Express device,
Yeah.
which is fair enough.
Okay, so and you think it's sensible to implement it all the time over U-boot? Because obviously there's going to be very good Linux support for Ethernet. So would it make sense to try to do some kind of Pixie implementation on top of Linux, like minimal images on some in Flash or on an SD card, which will then fetch over Pixie or whatever protocol some good information to deploy the image? Actually, you didn't really respond to my question. What's the use case of it? Like, what's the goal? Like, do you start an installation to deploy an image, or is the image pre-built? Do you do a live installation and then use that?
It could be either install images or just nodes that don't have any local storage. And so that's one reason for not doing it in Linux is just size-wise.
Just in RAM, they need RD, and when someone they need RD in RAM.
Yeah.
Like web server computation.
And you don't have the Pixie part, you don't have to put into local storage.
Yeah.
To SD or SAT.
So your U-boot is loaded from Flash? Okay, right. So could we implement, you choose to implement Pixie within U-boot itself? Could we implement it as a kind of U-boot payload?
So that was our initial implementation, was as a standalone U-boot app. And we moved to go into the route of making it a command within U-boot.
Why did you decide to move to within U-boot?
Just so you have one image to load. And to be able to upstream it.
So what were you think of the idea of loading Linux and then having a Pixie client on the Linux fetching Pixie data and chain loading into that with KNX and whatever?
That could work as well, on some platforms.
Need to finish back up and load.
Sorry?
It's back on load.
Oh, cool.
So rather than some instances it's used for bare bone initialization, right? So on a rack servers in there's no OS image available
Right.
to it. So you put your own example that's in that situation.
Okay, so,
Because like typically, at least the PXE protocol itself is implemented in the BIOS on the PC.
yeah, so when you buy a PC, you can boot with the network. And in fact, there are some publicly run PXE servers, and you can just remote install a Linux distribution by entering the IP like 9, 10, 11, blah, 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 and it boots off the network and goes to the Linux distribution or whatever, which I find really cool. What about the server-side needs of the PXE server? Like, is it easy to host such a PXE server? Do you need to, do we need like new types of servers, like being able to serve different images based on the IP requesting them, or is the current implementation good enough? What the end-to-end pieces which you think are correct, good enough, and the ones which are missing?
I'm not real sure. I think the standard DHCP server has all the PXE support in it.
Yeah, there's nothing special on the server.
Well, for instance, if I want to serve a different image depending on the IP which connects to me, is that possible today?
Yes.
For a DHCP server it is, for
It's
a
actually
TFTP
fine.
server it's not, I think. I didn't see one, maybe. I don't know.
Well, of course, you would just have you'd give a different boot file name.
Yeah, sure, but
To
where's
the
around
different
that?
machines, yeah.
I'm just making up problems because I'm not sure exactly what needs there are in the problem space. So, okay.
I think the server side's in pretty good shape because it's widely used for x86.
Close that session. Okay. What were the other questions I was asking? So how many different use cases would you have for that? So one case you said is just loading over PXE and then running it off RAM, no local storage, that's one use case. And the other use case is what, loading an installer and installing the system and then rebooting, I guess?
Yeah, I think those would be the main two.
Certainly from validation, probably do those.
That's it.
The installation would be also interesting from my point of view, because for a number of reasons, let's just call it paranoid lawyers, we are not allowed to ship full file systems with our boards. So what we do now is we just ship a Debian net installer, with the kernel installer. So in this way, we are not shipping any third-party IP, except for the reviewed limited selection of kernel plus Debian installer.
Actually, you touched two interesting things. So, in case you're doing PXE boot, how do you tweak it? Let's say you want to do an automated install, automated run of RAM. How do you pass parameters to the run system? Like, PXE can pass kernel init RD. How do you pass things like, I want to install that package on the local system, or I want to start this RAM payload, but with these parameters?
I think it's been with seeds for the network installer.
Yeah, how do you pass the seed? Because do you control the kernel command line? Over
Yeah, I don't know.
The standard PXE in the cat world, you actually, when you first load, it's actually instructed to download a sort of mini kernel. It's actually read the pxeboot.cfg, and then
where do you write it? Where do you write it?
On the FTP server. So the DHCP instructs the Intel machine to boot a specific file, which is a sort of mini group of the web, of the TFTP. So once this file is loaded, it then loads from the same IP of the TFTP server the DCF configuration file. So would it be something like that? I mean, I'm not really aware of the boot, how the boot can work of the network. Would it be able to read a configuration file and pass it?
Yeah, so actually, what's your TFTP implementation look like? Like, can you load U-boot commands over TFTP? Can you just load a kernel in ARD and boot them, or how do you pass kernel command line to it?
So you could do any number of scripts you wanted to run with U-boot before you even get to the Pixie boot command. And with the hush shell and U-boot and script images is fairly flexible.
So your TFTP implementation allows loading any U-boot image time, and so you could load a U-boot script, which then uses TFTP to load kernel and stuff. Is that right?
Right, but normally in Pixie case, the Pixie part of it is loading the kernel.
Yeah, that's
So you
exactly
do
what I'm
it-
asking, because if you're saying I'm going to do a Pixie boot, then it's going to load the kernel in ARD and boot that, but where do you find the kernel arguments?
I was just looking to see if that's in the config file.
Yeah, it is. It's in your PXE Linux config file.
But are you guys using Pixie Linux? I'm not sure.
Yeah, it's a subset. Don't ask me what it's missing.
Is it always TFTP?
Yeah,
Okay.
I think that's all Pixie supports.
Okay, so what about, so when you're installing to local storage, do you care about getting all the network data? Like, do you expect to still get information about the, so let's say you're doing an install image, you do your install, you reboot your system into your installed image. How first do you trigger booting to local storage instead of booting from the computer? How do you switch between the two?
Probably changing the U-boot configuration.
Okay, so you need to be able to write it to SD or to flash. Okay, and how do you revert that? So let's say you booted your local system and it hangs, and you have this park of thousands of machines, and you'd like to do a Pixie install again. How do you trigger that again?
Good question.
Okay. I guess one way to do it is this boot script again, so that it's server-side. All the time you load the boot script from Pixie, and the first time it says do an installation, and the second time, once the installation is complete, you switch Pixie boot server-side after the download is complete or something to the one which says boot locally.
Right. And Pixie Linux does have the menu capability, but that only works if you have a local serial port.
Yes, so I mean, this Pixie Linux, is it working on ARM or what's Pixie Linux? Is it like a payload which you can build C code, which you can build and run on ARM, or?
It's based on Sys Linux.
Right. It needs some kind of interface, so I guess it needs to be able to talk to something. I mean, it needs to output cartridge somewhere, and if it's on SoC and the Linux kernel is not running yet, you need some way to chat with the serial port. Does someone know Pixie Linux implementation? What is it like?
It's been a while since I've used it, like 10 years, but
Me too.
the way it works is on the server side, you can have a configuration script that is rooted down as far as like the MAC address or the IP address or the IP address range, for example. So on x86 systems that have fixed MAC addresses, you can actually have a single configuration file for each individual system.
Sure, that's good. That's the DHCP config, and that points out which files you're going to download. And what Rob was saying is that there is a local part running on the physical ARM system, which offers a menu to allow you to choose between various types of images. And the question
Well, the way
is,
it works is on the server side, the server side just sends the PXE Linux payload, which is like syslinux, to the boot machine. And the boot machine goes back to the server and looks through the TFTP subdirectory structure for that config file based on its internal MAC address.
so I can imagine, well, not even that. So how would Pixie know to fetch over the network when it's run from U-boot? You need some way to access a network. You need some functions to call to read, write,
Right, so
network paths.
the way you're going to have to get it to work would be U-boot would have to do a TFTP request to your server, and the server would have to download a PXE Linux load to the system. It's kind of like another layer before the kernel.
Yeah, exactly. But the problem is that you need, in that layer, you need to be able to do networking and serial port output.
Right, well, PXE Linux already does that, but...
How does it do it on ARM? Because
It doesn't work on ARM currently.
But you were
ARM
using
doesn't
it,
use syslinux.
you were using it on ARM. Are you using Pixie Linux?
Uh,
Or did I
We're
misunderstand?
emulating Pixie Linux in
Okay, so you're not actually using Pixie Linux the software. You're doing the Pixie protocol and passing the same type of config files, but with U-boot
so on the
itself.
server
and not-
side, we're compatible with Pixie Linux.
Right. So it sounds like what you're doing is doing a TFTP search for the payload based on the MAC address of
Right.
the boot machine. Okay, so, yeah.
I guess that there should be a way that on the ARM server you should decide whether you want to put off a local storage or a network storage, because it is easy when you're in front of an Intel server. You can press whatever sequence of keys to boot off the NAT. Okay, so should be a way on U-boot, say for example hold down control F1 whatever key to boot off the network. Otherwise boot local.
Yeah, so what I was saying earlier, that you could switch the Pixie script, or whatever you would load over TFTP, you could switch the sequence of commands, of U-boot commands that you download, so that it triggers a local boot once the install is complete.
Yeah, but the problem is that when you do massive deployment, is that you waste time doing a TFTP request that is not required.
Well, you propose pressing a key on the machine?
To boot off the network. Pressing a key, I would say, I don't know if it's a key, a switch, or whatever, I don't know.
So I mean, the first solution I'm proposing is without any human, and the solution you're proposing is with some human. So to me, it sounds not adapted to the center of
In
the
the
problem.
validation lab, we have to have it, so there's no human intervention whatsoever.
Okay, well, let me give you a little background of what I used to do 10 years ago when I was at Intel doing mass system deployments. The systems would boot up first to PXE Linux. And if there was a config script for that machine, the config script would look to see if it had a local image or not. If it didn't, it would do a network boot, do a network install, then reboot, and then go, oh, well.
Yeah, but there's, I mean, if the local state is, there is an image which seems installed but it's broken, how do you recover from that?
If you have a broken image on the local system, that was where manual intervention comes in, but you don't actually have to hit the physical machine. I can just remote into the server and change the config script, the PXE Linux config script.
Yeah, that's what I was proposing earlier, that you always put up the Pixie script of the network, and then you decide whether you install or not.
It added a little bit of a delay in the boot thing, but I could manually, or I could deploy systems across the world without actually having to be there to push a button. So that was the major advantage that I had for deploying PXE Linux.
Well, you just lost all the
I'm sorry?
text as well.
Oh, what happened?
Do you undo quickly?
Yeah, I'm also saving the text I just typed, so. Ooh. Why I'm not getting the text back? That smells crap. Crappy Etherpad. Now it's, in the past UDS, for people that had multiple UDS, was Gobi crashing all the time. And now it's Etherpad. I'm so pissed off. I hope there was a text before that.
There's something back.
Well, it's what I saved before trying to undo, but it didn't work to undo, so I'm a bit pissed off. Okay. So we were saying, so which bootstraps? So it seems there is this. It's U-boot in any case, then TFTP loading U-boot commands, or directly can 8RD, depending on the Pixelinks config. So maybe U-boot boots loads over TFTP Pixelinks config, then passes that, then decides to either load a U-boot script or can in RD, and then runs that. And that's all the same thing. And once you install, the U-boot script is just saying boot locally instead of TFTP load kernel and what about NFS? Like, is this something which is relevant, which needs to be part of the testing sequence? Does it relate to?
Yeah, but I think NFS is pretty well supported already.
Okay. Doesn't need to be part of the prototype in any way.
Only if you want to never have local storage. Always boot off the network, boot a kernel off the network, and have your root file system off the network.
But that can be handled after it finds a boot config. That can be part of the boot config.
So I think one way to dodge problem of installation is saying whatever you're installing has some standard way of expressing what payload you want on the local storage. So in the case of Debian installer, there is a way to pass preceding. In other install environments, there is Kickstart, I think, to express that. I think for Red Hat at least, and I think Ubuntu has some compatibility mode. What kind of payloads you care about? Like, is this custom payload and you're going to build your own anyway, or you're going to provide multiple ones depending on the target operating system, or do you have like standard implementations of the payload which you would like to be supported in ARM cells?
Right now, probably the main one is Ubuntu server install. Do you mean particular configuration of that, or?
So, I mean, for instance, do you care strongly about deploying Debian style images, Ubuntu style images, or Kickstart images, or any type of images? Will you extract it away, or?
Yeah, eventually we'd like to support anything.
But it's anything Linux.
Yeah.
So, do you need to access, so let's say you want to diagnose what's going on each node. When it's doing this Pixie boot, you want to follow what's going on, like where is it in the Pixie loading sequence, how far did it go, whether it worked or not, which step failed. How do you track this stuff? And do you need to make it available to the installed system? So let's say you're doing an installation sequence and you're saying, I can imagine a typical scenario. I went through, for instance, to order an x86 virtual machine or an x86 node from whatever provider you can think of. You go to web UI, you say I want this type of server, I want this type of OS, and then there's a nice progress bar which tells you what it's doing, and you maybe select some options like I want to use Red or I want to use a LAMP stack, whatever, you install the right packages, and in the end you get your installed system, you connect to it. Now you probably want to give some progress information you probably want to give some way to give input, output, and you probably want some logs or tracking of the results so that you can diagnose issues or just have reference of what happened. Do you need that infrastructure side? Do you want to keep that on a local node? Do you want to keep, what part of the dialog do you want to keep?
I think it would be done out of band.
What do you mean out of band? Like on a serial console or like some special mechanism specific to the SoC? Or?
We have another way to get it.
Okay. Okay. So one big open question is relation of UEFI with all of that. Like, so one big issue is that there is no standard boot image, right? So you gotta provide an ISO or CD-ROM image which you can boot on thousands of x86 systems right now. So that doesn't exist on ARM. There's no USB standard image, there's no CD-ROM standard image, and there is no network standard image. Now PXE is standard protocol, and it's good that it's based on standard information and standard protocols like TFTP. The question is, will UEFI change that in future? Like, will we want some kind of UEFI network standard? Or ARM boot standard, which is using UEFI or not? I mean, I'm not saying we should use UEFI, I'm saying maybe UEFI will play a role there.
Perhaps, I mean, it kind of depends on what people want in terms of UEFI.
What about passing data about the SoC you're loading? So, I mean, it's quite easy to imagine a build farm where you're keeping all the same systems in the same pool and they are all the same types of port, but what might happen is that you have different types of ports, or you're setting up different types of nodes with different sizes, like one has more memory, or one has no local storage, or one has the new version of the SoC, and you still want the same infrastructure to deal with them. So of course you could abstract that away with network tricks or multiple deployment servers, but maybe you want to pass that information dynamically so that when you're doing your PXE request, you include the SoC name or something like that? Do you do any of that, or is this relevant?
So you could extend PXE Linux to load device trees. Is one way.
Oh, hold on. Yeah, okay, sure. You could pass a device tree, but the device tree assumes you already know what your node is. What I'm saying is maybe the node should pass information about what it is to the PXE server so that it can dynamically offer a different config. Does that make any sense? Like the other way around.
Yeah.
You're talking about for supporting like different hardware models, essentially.
Yeah.
So we had something similar to that when I was doing my PXE Linux stuff. And all I did was I had a small handful of basic PXE Linux config files, one for each model of hardware. And then for each MAC address, which is how I controlled each individual system, instead of having them have their own specific config file, I would just symlink them to the central config file for that hardware model.
Yeah, so that's very manual, and I was hoping for something like more dynamic. So I'm trying to figure out a way to pass information, because the MAC address is like supposes that you have some external way to track the information. But imagine you could pass things like in your PXE request, I'm in OMAP 4. So
there are in the initial bootp packets, there are some strings that you could dynamically change. I think it's the UUID and like a name string. And then the file you get back is based on that.
Right. And
all right, that's a good one. You could use the node name as a way to set that. So you could set up the node name in uboot config to OMAP4-500 megs of RAM.
Right.
And it would select different config. Yeah, okay, that's a good one.
the question I have is how would something like that work on, say you had a whole rack full of Panda board systems? Well, none of them have assigned MAC addresses.
Yeah, oh, that's a good one. You mentioned MAC address earlier, and I wanted to bring that up, and I forgot about it.
As a matter of fact, I don't know of any dev system that is going to have an assigned MAC address, because MAC addresses have to be, to get an actual assigned MAC address in hardware, the vendors have to go through some committee to get it.
Boards have valid MAC addresses.
Right.
Your bots have valid MAC addresses because they are real. So you're saying real server hardware
Well,
will have
Freescale,
ROM?
I know something about them.
Yeah,
you
usually,
said-
usually vendors shipping a hardware with the embedded Ethernet, they do have a...
No, they don't.
No,
Panda boards
Panda
don't.
to extent don't have the ROM.
Panda board stands out as it doesn't, most do. Most do in my experience, it's just the Panda board.
I don't think
Panda
the
board
Beagle
and
did either.
Beagle XM I think as well.
Right.
The Beagle XM didn't, I don't think the Babbage did, I can't remember if it did or not.
And I think the regret, well, Babbage, I think Babbage has a unique MAC, but it's not in a ROM. It's stored in the UBoot config.
Right.
But for instance, one thing they did on Panda is generating the MAC address based on the die ID. So I think we should start from the assumption that you have some way for all the MAC addresses to be unique, because otherwise there will be no
Yeah,
network traffic.
That's way down at the kernel level, and we're talking about a U-boot, which is...
No, you can do it in UBoot.
Okay.
You have the die ID in UBoot as well if you care about it.
Freescale chips can put the MAC in fuses, defuses.
Oh, keep in mind that you have to access the network to get the PC configuration anyway, so your MAC address needs to be valid at that time already.
I know,
Yeah.
that's what I'm saying, right now it currently isn't. So unless U-boot fixes that, at that level.
Okay. Okay, so what do we want to get out of that? So I think we did. I'm happy with the kind of in-depth discussion we had about the various PC sort of use case. Does someone else have other use cases which we didn't mention, or other sub-problems which are related to this network boot of ARM servers, automated deployment of ARM servers, this type of stuff?
Well, it doesn't even have to be limited to ARM servers. I mean, another usage case for this type of a deployment would be for diskless workstations. So, which I believe the OEM team has already got a project they're working on. I'm not sure.
Yeah, that's a good one.
So one interesting thing would be to not use TFTP, a different protocol like HTTP or ISPsy, because TFTP has similar limitations.
Yeah, also I'm not very, I myself, for instance, I have a home server and I'm not comfortable with running TFTP on it because, well, it's insecure. So of course you're in a controlled environment, you can shut doors off and stuff. But, you know, inherently these TFTP servers are a bit scary things. They're not very flexible in configuration when compared to an HTTP service where you can do tons of stuff. So there's a question of whether it makes sense to use something other than TFTP. Yeah, that's a good one. So is this something which you consider? Like, you went for a standard Pixie implementation.
Sure. We want to fit standard implementations and not deviate.
Yeah, there's a good argument for going with that because it's what a lot of server people are already comfortable with.
Right.
But HTTP is also something which people are comfortable with setting up more than TFTP, in fact. More people are able to set up an HTTP server than a TFTP one.
Oh, sure. In terms of normal day-to-day running, in terms of installing servers, TFTP is accepted.
Yeah.
Sure. I mean, it's okay to say TFTP is required, but there is a question to be made of whether we could do something better with HTTP where you'd be more flexible.
Right.
Like
Well,
the
then you're
example-
talking about more overhead. And I'm not sure how much overhead you really want to throw into U-boot. I mean, you've already got all that support when you get to the
Right.
kernel, so it's kind of moot.
But for instance, Red Boot supports HTTP.
I don't think so.
Oh, it does. I have an ARM box at home, which is a Tecus, which is an ARM-v5, and I can just HTTP load the kernel and inRD, and it's very handy to test new installations.
So,
I find it really cool, but because it's much easier for me to set up an installer, and it's easy to host it over the network, and then you get benefits like from hosting and stuff. But I agree with you; it's a much more complex protocol, and there's a lot of overhead to it.
so a PC with a gigabit Ethernet does TFTP downloads at 40 megabits.
Yeah, but your TFTP download payload is really minimal anyways.
That's
40
512.
megabits, you can download that in a second on a DSL modem, so who cares?
But you said TCP would be more overhead, but
No, TFTP is minimal overhead, that's why they use it. because
It's simpler. It's a simpler protocol.
that's what they implement in gigabit and 10100 network cards in their firmware, because it's minimal. You know, Intel network cards have TFTP implemented into the EEPROM because it doesn't take very much overhead. It's hardly any code. When you start adding HTTP and
Yeah, I think it would
FTP
be
and all
a lot.
those protocols, then you're creating a larger overhead. And embedded systems just don't have that capability.
I agree. I think it would
does
be a much
Ubuntu
bigger
have
system to get
TCP?
TCP. Sorry.
Does Ubuntu have TCP? Only UDP?
The GPXE implements multiple web protocols. I guess that they are limited, and they still can limit their code into a few hundred kilobits, so it can be done. The stock firmware PXE implementation can be replaced with GPXE with HTTP and a few other protocols implementation, so it can be done in small code. With sufficient support for routing together.
Yeah, and we should
features.
Right, and we should mention that GPXE is the new name for Etherboot.
Oh, yes.
So I don't think there is HTTP support for U-boot written anywhere. I think there is TCP support because there is telnet support for U-boot. Like I think there is some U-boot where you can telnet into it, but it might be just marvelous U-boot. I'm not sure. There's TFTP support in upstream U-boot, right? But you added the PXE support to it, right? So you added parsing for PXE configs to the existing TFTP support.
Right.
And yeah, HTTP would probably be too big. Like, you could probably come up with a stupid HTTP implementation that wouldn't be compliant or something. But it would be possible with the Linux use case, the way you load Linux, and then you load the payload by HTTP, and then you say exactly that. That would be completely possible, and probably easier than TFTP get, whatever. Okay. So what do we make out of that? I need to wrap up the session a bit. My feeling is we want to demo two things. One is putting a stateless system which is just configured to always load its payload from the network, and it just runs something off the network. So maybe a good demo is just serving some files of HTTP, like running a minimal web server, building a kernel and initrd, which you can start off the network over PXE, and they do something useful, like showing a penguin or whatever. And the other use case is sending an image of an installer, deploying to local storage, and rebooting into it after switching the PXE config or perhaps something like that. Is that good enough a demonstration? Like, is that the type of prototype we're looking for here to cover the use case of ARM7 future, or do we miss something big by doing that? Are we happy with that?
How do you get to select which image you install?
So that's kind of the discussion we had about the config earlier, which is about saying the node name, what might include information about the board, like the SSC name. You have the MAC address information as well, and in your DHCP set configuration, you point at different directories.
So you describe what you want to install underneath itself.
Right.
Channels.
Okay, so boot of network and run some network payload back. Loading star of network and load into local storage. Maybe we want to demo installation of some packages, like list of packages, something. Okay. And you will find this for future. Okay. Anything to add to the network prototypes demo notes? Are we happy with the outcomes of what consists of the prototypes? Is this a good statement of work?
Just briefly, I'll just go back over to them.
if you said load the image, put it on local storage and then reboot, and I want to just reboot that local image, I don't want to do that again, is that a manual?
Yeah, so what I was saying, that's the question I was saying earlier, that if you configure to run off the network all the time, you want it the next time it boots to boot off the installed image.
Yeah.
So one way to implement that would be to say at the end of the installation, one step is to send a message to the server that the installation succeeded.
Right.
And then the server, the next boot, won't serve the installation image, would say, just boot on that off.
Yeah, that's exactly how I had my system deployed at Intel, is every time it would reboot, it would actually go and grab a PXE config file, but if the local image was valid, the PXE image would just time out and it would just boot locally.
Right.
But the server would actually control whether or not, if I needed to re-image machine, the server would just say, okay, run this config file next, and it forces it into a re-image cycle.
Right.
So.
When you plan to publish your PXE stuff, you said?
Sometime in the next couple months.
Okay. So did you think we should wait for that before working on Prototype, or shall we start with custom implementation of TFTP commands just as a demo?
So if y'all are ready to get started, we could provide it sooner.
Okay. Okay, so you say we should start and keep contact with you, and we'll get the fixed implementation soon. Okay, sounds good. I'm happy to close the session 5 minutes early, and let you guys enjoy other sessions, whatever.
This is the last one.
Yeah, exactly. I mean, going right now to another room, I guess they're also on. Thanks.
I think you like